Hello friends, welcome to the session. In this session, we'll be discussing about linear arrays. In this session, we will see what we mean by linear arrays, how linear arrays are represented in memory, and we will see one operation and the algorithm of that operation. This operation will be the traversing operation on the linear arrays. That is, in the traversing operation, we will visit or we will apply process to each and every element of the array. So we will see how we can write the algorithm for traversing all the elements of the array. Friends, as you know that I am recording this session for PSS Central Institute of Vocational Education, and the course for which we are recording it is the Junior Software Developer course. And this is the session on the data structure. But the students from other courses who want to learn data structure or who want to learn computer science can also make the use of this session. So friends, let us start the session and let us understand what we mean by the linear arrays in the data structure. So linear array, as we know, the name linear indicates that it is a sequential arrangement of elements. So whenever we have a list of elements, then this list of elements can be arranged sequentially. Sequentially, it means one after the other. And whenever we have such list, then we can create a data structure called an array. And in this data structure, we can store the elements one after the other. So the array can be of one dimension, that is, we can store a single row list or a single column list. Or sometimes you will find that we can have an array of 2 dimension or 3 dimension or even more than 3 dimension as well. As shown in this figure, one can easily find that we have an array which is a single dimensional array, and these are the array elements. The first element is 25, the second element is 40, the third is 65, fourth is 98, and last one is 100. So these are the values of the elements. And these elements can be accessed by using the index, and the index normally starts with the number 0, but it is not necessary that every time the index will start with 0. It is possible that you can start the index with 1, or even if I want, I can start the index with 100 also. So there is no restriction. And the second element will be having the index 1, the third element will be having the index 2, then the next element will be having the index 3, and the last element will be having the index 4. Also, you will find that in the one dimensional array, there are 2 pointers. The first pointer is the lower bound pointer. So it will mark to the first element of the array, which is indicated by the index 0. And there is an upper bound, and this upper bound will mark to the last element of the array. And in this case, in this example, the last element of the array is having the index 4. So whenever I write, suppose A is the name of the array, and in the square bracket I write 5. So whenever I write such kind of the thing, then it will refer to the 5th element of the array. So this 5 will refer to the index number. So the 5th element of the array can have an index 4 if I am starting with the index 0. If I am starting with the index 1, then the index number for A5 will be 5. Like a one-dimensional array, we can have also a 2-dimensional array. So whenever we have been given one table where the table consists of rows and columns, then you will find that in order to store such data, we need a 2-dimensional array. So 2-dimensional array will have the rows and columns, and the table of values can be stored in the 2-dimensional array. And whenever we require a 2-dimensional array, then this 2-dimensional array will require the 2 index variables. So as shown in this diagram, suppose we have a table of 3 rows and 3 columns. So the column index will be 0, 1, 2, and the row index will be 0, 1, 2. So the first element will refer to the 0, 0, index 0, 0. Then the second element from the first row will indicate the index number 0, 1, and the third element will have the index 0, 2. In this way, the first element from the second row will have the index 1, 0, then 1, 1, and then 1, 2. And the third row will have the first element having the index 2, 0, then 2, 1, and then 2, 2. So in this way, whenever we write A2, 3, where A is the name of the array and 2 and 3 are the index numbers, where the 2 will indicate the second row and 3 will indicate the third column. So this is an element which is from the second row and the third column. Whenever we have been given an array, then we can perform different operations on this array. Say for example, whenever we want to add an element into the array, then this operation is called as the insertion operation. Whenever we want to remove some element from the array, then this operation is called as the deletion operation. Whenever we want to visit each and every element of the array, then this operation is being called as a traversing operation. Whenever we want to find whether a given search element is present within the array or not, then this operation is being called as a searching operation. And whenever we want to arrange the elements of the array in increasing or decreasing order, then this operation is being called as a sorting operation. Apart from that, it is possible that we can merge two or more arrays together, and this operation is being called as a merging operation. So all of these operations can be easily performed on array. But as far as this session is concerned, you will find that we will be discussing only traversing operation. Because whenever we discuss any operation in relation with the array, then we need to write an appropriate set of steps, and that is being called as an algorithm. So we need to write an algorithm to perform any operation on the array data structure. But before we go for the discussion of the traversing operation on the array, let us understand how the arrays are represented in the memory. So whenever you have been given a set of elements, or whenever you have been given the array, then these array can be stored into the memory location. And in order to store into the memory location, what we require is the successive memory location. We require a certain amount of space in the memory where all the elements of the array can be stored one after the other. As shown in this diagram, suppose we have been given some memory locations where the starting address is 1001 and the last address is 1016. And then you will find that within these locations we can store about 8 elements of the data type integer into the memory. So the first index here I have indicated as 1 and the last index I have indicated by 8. So it is not necessary that always you should start with the index 0. You can start with the index 1 also. So the first element in the memory address is being called as a base address. And by using the base address, we can easily calculate the location of the exact element into the memory. So if we have been given a linear array, and suppose we use the term LA, L will stand for linear, A will stand for array. So if the base address of the linear array is indicated by base LA, then we can easily calculate the address of any element of the array. And for that we will use the formula location of LAK, where we want to find out the kth element address. So base LA, we will take it, and then we will add plus W and K minus lower bound. So whatever is the lower bound, that we will subtract from the kth position, and then we will multiply it by W, where W will stand for the number of words per memory cell. Friends, you must know that whenever we want to store some integer values into the memory, then for one integer value we require 2 memory locations. If you want to store float values, then you may require 4 memory locations. If you want to store a string value, a character value into the memory location, then you may require only 1 byte or 1 memory location. So depending upon what kind of words you are storing into the memory, as per that your W will go on changing. So as far as suppose for example, if my base address is 1000, say for example, and my word is 2 bytes and my kth position is 5 and my lower bound 0, then I can calculate the address of my fifth element as 1000 plus 10, which is just nothing but 1010. So the memory address of any element of the array can be easily found by using this formula. So this is the formula that we need to refer whenever we want to calculate the memory address of any element in the array. Now we will go for the traversing operation. Traversing operation, as I told you, that this is the operation which is performed in order to make an access to all the elements of the array. So in order to understand that we are making an access to the elements of the array, let us apply some process. So the process can be anything. Say for example, I will just visit the element, or I will read the element, or sometimes I will print the element, or sometimes I may add all these elements. So the process is to be applied to all the elements of the array. So accessing each and every element of the array exactly once is being called as a traversing operation of the array. Now, as I told you, whenever we want to perform any operation on the array, then it is necessary that you should write an appropriate set of steps. And this set of steps is being called as an algorithm. So let us understand how we can write the algorithm for performing the traversing operation. So the first step in the algorithm is that we have to initialize the counter. So what I will do is that I will set k, and the initial value of the k will be lower bound. So as we know that the array will have the lower bound and upper bound, so I will set k is equal to lower bound. Then I will repeat the steps 3 and 4 until or while k is less than or equal to upper bound. So the value of the k should always be less than or equal to upper bound. We do not want to go beyond that, isn't it? Because our array is always between lower bound and upper bound. And then what we will do in the step 3 is that we will apply the process to the LAK. LAK means k is the lower bound. So we will apply the process, means we will read the first element of the array. And then we will increment the value of k by 1. So we will go to the next element. And then we will again come back and we will apply the process to the LAK. So in this way, we will repeat the steps 3 and 4 until our value of k is less than or equal to upper bound. As soon as our k value becomes greater than upper bound, then we will simply exit the loop. So in this way, we can easily access each and every element of the array. And you will find that we are applying the process. As I told you, the process, what it means, the process means just reading of the element of the array, or sometimes we print it, or sometimes we can make an addition of all the elements of the array. So this algorithm is a very simple algorithm, and if you compute the complexity of this algorithm is of the order of n, where n will stand for the number of elements of the array. So if there are 10 elements in the array, then you will find that 10 times you have to apply the process. If there are 100 elements in the array, then 100 times you need to apply the process to the elements of the array, and therefore the complexity of the algorithm will be of the order of n. Now let us understand this algorithm by taking one simple example. Suppose I have been given one array. Suppose my first element of the array is 5, the second element of the array is 3, then I have the element of the array 4, and then finally I have the element of the array 25. So suppose I have been given an array where there are 4 elements. Now according to the algorithm, you will find that this is our lower bound and this is our upper bound. Now suppose our lower bound is 100 and our upper bound is, so initial value of our k will be 100 because k is set to lower bound. And then what we will do is that we will apply the process to LAK. So LAK means we will read the first element of the array, that is 5. Then we will increase k by 1, so it will become 101, and then we will visit the next element of the array. Then we will increase k by 1 again, so that we can visit the next element of the array. And again we will increase k by 1, so that it will become now 103, and we will visit the element of the array. Now if I increase now k by 1, then it will become 104, and 104 is greater than the lower bound of the value, and therefore we will exit the loop. So this is the simple algorithm with the help of which we can make an access to the elements of the array. Now once you understand the algorithm, then you will find that you can convert this algorithm into a program. And for conversion of algorithm into a program, you need to be familiar with certain programming language. So for example, if you are familiar with C language or C++ language or Python language, then you can make the use of the language for the conversion of this algorithm into an appropriate program. And once you prepare such program, then you can execute it and you can see whether your program is performing correctly or not. So if your algorithm is correct, then your program will also be a correct one. So thank you friends for viewing the session. Hopefully you have understood what we mean by array and how we can develop an algorithm for making an access to all the elements of the array. called as the traversing operation of the array. Thank you all.